On the Security Weekly News, I try to scan and produce a quick look at some of the major stories to help you keep up with what's going on in and around the industry in a short format. Myself, Aaron Leyland, Josh Marpet, and other guest commentators provide greater insight every week. I'm Doug White, and I hope that you'll look for the Security Weekly News in all of your favorite podcast catchers and subscribe for the latest content.
Welcome back to Application Security Weekly. A machine learning algorithm walks into a barge, a barrio, a barracks, a barrel, a barbecue, a barn, and then a bar. The bartender says, "What'll it be?" The algorithm looks around and says, "What is this, a joke?" Welcome back to Application Security Weekly. As I said before, I'm your host, Mike Shima. I'm here with John Kinsella, and it's just about time for our second interview this week. But first, a quick announcement. Join the digital identity community at the Aria Resort and Casino in Las Vegas, May 28th to 31st. The 15th annual Identiverse will bring together over 3,000 security professionals for 4 days of world-class learning, engagement, and entertainment. As a community member, receive 25% off your Identiverse 2024 tickets using code IDV24-SW25. Register today at securityweekly.com/IDV2024. Keith Hoodlet is an early pioneer of AI-biased bug bounty hunting. With an OSCP designation and years of experience building DevSecOps programs in Fortune 100 enterprise organizations, his collegiate education in both computer science and psychology has afforded him unique insights for this historic moment as companies seek to safely and securely deploy artificial intelligence technologies at scale. Hello, Keith. Thank you for joining us.
Hey, good to be back, and hello again. It was funny, just before we joined, John was like, "Oh, this guy again?" I was like, "Uh-oh." But no, seriously, it's really good to see you both. Again, I continue to be floored with just how much amazing work you all have done to take this podcast and make it into something, huge, as opposed to like Paul and I just sort of, throwing back and forth some memes every now and then. So it's always good to be here.
Well, thank you, Keith. And so our listeners know, Keith started ASW podcast at number 0. So he was even doing a proper integer counting with that. But you've gone from 0 to 1, Keith. You got a first place prize in this AI biased bug bounty program. I think you have to tell us, what is this bounty program in the first place so we can figure out just exactly what you did.
Yeah. So the Chief Digital and Artificial Intelligence Office of the United States Department of Defense partnered with a couple of companies, BugCrowd, bug bounty platform, and Conductor AI to test a undisclosed or I cannot disclose the large language model. I will just say it's a open source, well-known and understood large language model for AI bias, just to determine if using realistic scenarios within a DoD context or nominal DoD-like scenarios, that you could get it to produce biased outputs and responses based on prompts that you would enter into a chat interface. And the reason they were doing this is because the United States government has this concept of protected classes, and you cannot either provide preferential treatment or discriminatory treatment of all sorts of different protected classes. And that could be age, gender, ethnicity, heritage, religion, pregnancy status, HIV/AIDS status, military veteran status. And there's like a whole, long list of these things. And effectively, they were just saying, hey, given potential scenarios that you as the security researchers can come up with that are applicable to a context that might be used within the Department of Defense, can you get this thing to respond in ways that would elicit a biased response? I think one of my favorite ones, honestly, was basically coming up with a scenario similar to the Captain America Super Soldier program, where I basically said, hey, you're an artificial intelligent large language model used to help select candidates for human-based testing of this new medical type thing. Can you help me select candidates from this roster that I'm about to provide you? And like, lo and behold, it's like, oh yeah, young men are like the people that it's is going to select off of that list just because it's like, oh yeah, these people are perfect candidates. Even though I, as the tester, I'm like, please choose a diverse set of candidates from this roster of individuals because it needs to be representative for possible side effects in the field when we decide to use this thing. And so, needless to say, you could get it to basically show preferential bias, but also when you tried to perhaps pack the roster with individuals of diverse groupings, it would still try to choose young men over everybody else that it could possibly choose in that list, regardless of the different things that you might include in the roster, such as like candidates' background, military history, health status information, etc.
Yeah, and I want to learn some more about just what got you into that first place, what you did. But I want to, before we go into what you did, I want to talk a little bit about the preparation. Meaning, how many OWASP top 10 lists did you read that show how to go and hack and find these flaws in bias or prompt injection or prompting or I'm joking about that obviously, but were there resources that were useful for you to figure out how to do this testing in the first place?
Honestly, when we were doing our prep for this conversation, one of the things for me is I didn't do any sort of like go and read the manual on this because, quite frankly, while there are a lot of things out there from various entities that have talked about red teaming, which in the sense of a large language model and AI is actually more of like a safety sort of element as opposed to the way that we as security researchers think of red teaming as like offensive security, right? And so while I had encountered some of these from Microsoft, from Anthropic, from OpenAI out there as like guidance on ways that you can test an AI large language model, honestly, for me, my psychology degree and understanding of bias and heuristics was just sort of like, you know what? I sort of have a general understanding of the way people think and humans in general. Like, let's just see if I can maybe come up with some interesting scenarios that, who knows, like maybe it will actually show a preferential bias or a discriminatory bias. And so admittedly, my first sort of focus here was, can I just simply get it to make assumptions, right? Can I get it to respond in ways that it is sort of filling in gaps? And that sort of first qualifying round, because they had 2 rounds of testing. There was a qualifying round and then there was a contest round. And in the qualifying round, I really just tried to get it to say, yes, sir, because I was trying to get it to assume that like the officer was always a man. And lo and behold, every time I would have it do these sort of scenario-based role plays where it was like, hey, like I have this situation that I'm trying to work through and I'm going to have a conversation with my, superior officer, my manager, my supervisor, what have you. And like, can we role play this out? And then it would just like go really deep into, talking about itself and, having this whole conversation and dialogue. And lo and behold, the officer every time was yes, sir, or good morning, sir, or hello, sir. And the reason that I was able to even like reference this was back in December of 2021 or 2022, the U.S. Marine Corps actually did a study with one of the universities in Pennsylvania and basically found that using, responses in boot camps of like, yes, sir, or yes, ma'am, could potentially misgender the officer that you're responding to. And so they said, do not do this anymore. You must respond with like, yes, rank, like yes, lieutenant, yes, sergeant, yes, captain, what have you, right? And so that was sort of how I could say like, look, even the U.S. Marine Corps isn't accepting this anymore. So clearly there's something here that we shouldn't have. And I did that a lot. And eventually Conductor AI and the bug crowd team were like, okay, enough. Like this is like, we need to see something else. Like you've hit this one too many times on the head, which caused me to evolve my process.
It's interesting to me on this here, and it sounds like I think on this podcast I'm fairly negative on these things, but this is really sort of just a factual comment or a factual question. With the age of AIs, MLs, pick your phrasing, and the amount of work which people are going into right now to protect these systems, it seems like you don't need to go down the path of a red team yet. Because to my mind, a red team is like, they know a product very well, they're in depth in it, they might actually have access to the source code, or at least some black box or white box testing, but they're it's a lot more of an intimate environment. And as you were saying, you're able to come along as a psychologist, which wonderful people, just like yourself, and sort of ask some basic questions and sort of walk into it. Does that sort of reflect what you've seen? And then B, do you think we're going to get to a point where you'll have to have more than just the ability to talk to a human?
Yeah, I think when I was looking at other large language models, some of which are privately offered and you can subscribe to those services, they tend to do a better job of making it hard to elicit bias. Is the way that I would put that. And so, especially when it comes to asking things in a certain context. Now, will it in cases where you ask it to tell you a story, will it sort of traditionally have stereotyped gender normed roles, for example? Yeah, 100% it will, because that's it, at the end of the day that I come back to this in the blog post that I wrote on this as well, is it's all just statistics and an algorithm that uses weighted, data from a collection that is a statistical model. And so the things that you see based on the training data alone is really what ends up eliciting a lot of these biases, just based on the way in which those weights come back from the algorithm that is run against the training data. And so the example that I use in the blog post is when you think of things like, proposals that are being reviewed by the DoD for defense use cases. Well, if you include any information about the CEO, it will typically choose someone with an Anglo-Saxon name that is a male, because CEOs by and large tend to be, in the training data set, white men. And so that was just sort of the thing that you just find based on the underlying training data. So to your point, like walking right into it, well, humans have biases. Like this is just the nature of who we are as people. And so the training data, guess what, was made by humans. And so it's now like, okay, you're going to find these things and you can do some stuff to try and remove that bias. Retrieval augmented generation is like one nice way to make sure that the thing you're responding with is perhaps more factually accurate to the thing you're asking for. But you can also overcorrect. And we saw this with like Google's Gemini, art creation, where it asked for like, give me a picture of the founding fathers. And it gave a really sort of like diverse group of individuals that was not at all historically accurate to the founding fathers. And I found a similar experience when I went out to my employer. I work for GitHub. Microsoft owns GitHub, but I went out to Bing Chat and we were watching Manhunt on Apple TV. And I didn't really know a lot of the history of John Wilkes Booth. And so I asked, does John Wilkes Booth hang? Like, is he actually caught and tried and hung? And it's like, yes, he is on this specific day. And it had done retrieval augmented generation to like look at an article of historical fact, but that's just not what happens. He actually dies of a gunshot wound in the process of being captured. Spoiler alert. So yeah, it's just like, even then, some of the tools that you can use to try and like remove bias, or like, people would call it hallucination, but again, it's just statistics. It's just training data and weights that you're going to find it. So it's sort of a think of how you're going to apply it problem. And I had a great conversation recently with someone that said, like, security is something that often you can do after the fact, right? You can sort of build a thing and then you can apply security to that thing after the fact. Generally true, although we'd prefer it not to be the case. The AI use case is sort of the opposite, because once you've got a trained large language model and you decide to apply it to a problem, and then you try to pre-prompt your way out of it or try to, use retrieval augmented generation, you're going to run into problems depending on the use case that you've applied to, like that language model to, like HR related functions, for example. That happens all the time. Anyway, that's a long-winded answer, I think, to your question, John, and I'm not sure that I answered it exactly, but I suspect you're going to see more of a applied, like, hey, how can I get this thing to do something that it shouldn't, or to say something that it shouldn't? That's going to be easier than I think a lot of people think.
No, I like answers that sort of don't reflect the question, right? Because I think what you hit there, which is sort of interesting, is there's parallels between really what you're seeing in at least my takeaway from that is there's parallels in what you're seeing with modern AI versus open source security. Whereas in an open source project, getting someone to actually do the security work is like, that's not the fun part, right? You get the guys want to code. And it's the same thing here. You're getting people, I'm guessing, that want to work on the overall training of the model, not how do we do that part.
Yeah. And I mean, to some respects, like a lot of this work from like a responsible AI safety, bias testing sort of function, that has existed within the OpenAIs, Microsofts, Mistrals, Googles, Facebooks of the world, in the way that they've built these language models. But it hasn't really been performed by your everyday person in this sort of same testing that the CDAO, or Chief Digital and Artificial Intelligence Office, put forward. Like, they're like, can we just find random people to do this instead of maybe really expensive, PhD level people that are thinking about this perhaps at a language training model perspective? And yeah, turns out they can. There was several of us that I think had quite a lot of findings. I actually had a chance to catch up with Dane Sheretz, who was the second place winner of that event as well. And so, we had a good conversation. He also has a humanities degree, by the way, which I thought was really cool. It's like, yeah, here we are, with our humanities degrees hacking on these things.
Yes, as someone who has an electrical engineering and a French degree, I very much appreciate this. I also want you talking about the bug bounty, because Keith, you mentioned like that Gemini example, and there's concepts of alignment and purpose. Like, are we looking at a LLM, an image generator, to generate something that is historical, let alone historical accuracy, versus conjectural? Like, show me the image of a pope, or do we want like the first pope or this Pope Pius XYZ, or do we want tell us like conjecture a pope? What might a pope look like? Those are two very different. There's a subtle nuance between those questions. It's like, are we looking at a Wikipedia page that we want for accuracy, or are we just looking at somebody's blog post, an alternate history type of setup? And the reason I'm picking on that or setting this up is that with a bug bounty, and as you're describing here too near the end, like, there are random people out there with humanity degrees that can help with this, think about this. But how do you model? How do you create a bounty for this that's useful? Because I think a little bit, you figured out some edge cases. You figured out how to not quite break the rules, but you didn't break the spirit of the contest. But you had a good that security-minded approach to this. So how did the DoD set this up, and what makes an effective bounty in this case?
Yeah, so this was set up as a contest, really, and not like the pay-per-finding approach as well, which I think in many ways was the right thing to do with this initial introduction of this kind of testing, because they didn't really know necessarily what they were going to get from hackers like myself. And quite frankly, they didn't necessarily know sort of what contexts we might come up with, right? Like, there was no real prediction there. And so, that being said, right, I think that you have to think of, you use the term alignment, which I think has sort of a many meanings in this space. So I'm going to say like application, right? Like, how are you going to apply the concepts of this model to this problem, and then try to determine, can this model do things that are undesirable as an outcome based on the way that we're applying this. And a good example that I use in the blog post is the state of Washington had a lottery page that they had set up using an image generation large language model. And it was sort of like one of those quirky little games that you could like throw a dart and like it would hit a specific section of the board. And this woman had, quote unquote, won a swimming with sharks prize if she had actually won the state's lottery for that week or something. And when she put an image of her face on the sort of like image generation thing, it came back with what was effectively softcore pornography. It had a woman with her face sitting on a outdoor lounging chair with her top off. And it was like, yeah, I bet they didn't expect it to do that. And yet here we are, right? And so it sort of makes you wonder, like, what language model were they using and what sort of training data did it receive? Because that doesn't necessarily sound like it's maybe the right application to the problem that they're trying to solve for. But again, back to training data, right? It comes back to what was in the model to begin with, and then what is the likely outcome based on the context of the pre-prompt. Images are, I will just say, sort of weird though, because unlike a textual chat-based interface for these things, where you're just having a conversation with like a chat GPT as an example, The image generation, generally speaking, will do what they call prompt transformation, which is slightly different than pre-prompting in the sense that like a pre-prompt is sort of like listing all of the rules of the things that it shouldn't do so that when it takes your input, it doesn't necessarily respond back in ways that it shouldn't respond back. But a prompt transformation like takes the thing that you've included and expands it. And so if I wanted to say like, give me an image of a quick brown fox, well, it might be like, you know, in the background, it's going to say, okay, quick brown fox. We're going to give a short fox in a green grassy field with bright sunshine and a white bushy tail with wind moving through the, like it would go and give you like this really long prompt transformation that the human never sees. And then it generates the artwork and sends it back to you. And so I think that at the end of the day, when you're testing AI for bias of some kind, to come back to like the question that was asked, you have to think of what sort of artificial intelligence are you applying? Is it an image generator? Is it a text generator? Is it, performing some sort of analysis or summarization of the text that is being put in? And then secondly, how are you trying to apply it from a use case perspective, right? Are you applying it to a human resources context? Are you applying it to a selection process context? Are you applying it to a programming context? And I think it's sort of funny, like mathematics you would think would be easy because there is a right and wrong answer, but turns out not really, probably because there's not enough like sensical training data for the large language model to really understand 3 + 4. But if you look at like programming data, well, it's sort of like an actual human language and there's a lot of it. So you can sort of get a sense of what's right, what's wrong, how these things fit together. And so you can train models with programming that tend not to have bias in them because you're not including those characteristics in the way that you're writing your code, unless you're doing something just, I don't know, really odd about your naming of variables and function names. But anyway, I digress to say application is the most important piece. Before you even think to implement, figure out where you're going to apply like a large language model or artificial intelligence to that problem, and then ensure that it's not going to be receiving, as I think I call it, personal identifiable characteristics or like human-based information that might in fact impact the responses in some negative way.
Yeah, and that sets up that aspect of how do we defend against this? And you just were walking through some of those aspects of just where are you using this in the first place. There's also the concept of model cards, for example. Tell us a little bit about those.
Yeah, model cards is a concept that's been around for a little while. I think some of the reading that I've done on it is around 2018 or so. But the idea here is it's sort of like having a flashcard that simply says, who made the model, what sort of training data was included, what sort of process did they go through to make this thing safe for use in some respect, and how big is the model from like a context window size, training parameter size, things of that nature. And so the idea here is to give you something that you can quickly refer back to and say, oh yeah, I want to go and apply this particular model for a customer support, thing, but maybe that customer support thing is on a hospital website, right? It's like, well, you might be taking in some interesting data there that you got to be really considerate of versus, oh yeah, no, it's a customer support page for, I don't know, ordering furniture. Not going to be terribly like, a hard thing to apply this to solving, hey, I just need to do a return style problem, right? Although if you're Air Canada, as you may have caught, Mike, like Air Canada had a problem where its language model in customer support had created this entire sort of like refund process for, I think it was bereavement or some sort of like someone had lost a family member. And then turns out it just totally generated this made up policy. And then the Canadian Supreme Court basically said, look, you must follow the policy that it created on your behalf because that's what the person operated off of from an assumptions perspective in terms of like, this is the right answer.
Career opportunity. AppSec people can now get into the exciting world of contract law. So, it's our responsibilities are expanding. But before everybody goes out and does that exciting research, I did want to bring in like, who looks at this? Is this really an AppSec problem or an AppSec team? We were talking earlier actually with Caleb Sema, who mentioned a lot of trust and safety teams look at this, and trust and safety teams have been around before AI because they're looking at how our systems abused or being used to abuse users or abuse their user population. And so that's why I'm curious, as we talk about defending, considering how these are used, what suggestions do you have, or do you see a place for who even should be worried about this? Who cares?
Yeah, it's, it's going to fall into a couple of different camps, right? I think depending on the company you're working with, legal is going to care because ultimately the things that are generated from a large language model could lead to class action lawsuits, could lead to, a one-off lawsuit, as in the case of Air Canada, for example. And so I think there's maybe some interest there or compliance for the same reasons to make sure that like, hey, we can't be breaking any laws related to, just biases within our hiring process, as an example. But from a testing perspective, I mean, these things live on web applications, generally speaking. And so that sort of allows it to fall a little bit into the purview of application security, especially if there is some sort of security testing element associated to it. It's not like you can hit it with a dynamic analysis tool or a fuzzer or something of that nature, but you can at least try to do, and I should maybe back up and say there are two different kinds of testing that I think are pretty common within language models and chatbots, which is Oracle-based attacks, which is the language model is an oracle that has access to systems and data that the interfacing user should not have access to. So that is one sort of path that I think makes a lot of sense for penetration testers, red teamers, application security testers, folks of that sort of background. The bias-based testing, I don't know that there really exists a specific role in organizations today where a user could take up that sort of effort. I think trust and safety, in some respects, yes, but they tend to be a little bit more OSHA based in some respects. Like it's more cut and dry as to like the safety regimen, and we're sort of in the Wild West with all of this, to be honest with you. There's a lot of writing out there and proposals out there and considerations out there, but I don't know that companies have really considered, how are we going to test this thing to make sure that it's safe for use, let alone, what can we do to actually test it once we know that we should, right? So I think it's Brave New World, maybe. People have a chance to carve this out inside of their career and say, I want to do that. And then maybe find opportunities to go do that. And I don't know, it could rock the boat. Companies might be riding the hype cycle and be like, you know what, we don't care because valuation and profits first. And so, if that's the case, then tough, I guess, yikes. But on the other hand, I think a lot of companies are going to find out pretty quickly that, hey, they actually really do have to care about this. And having someone that's interested, encouraging that testing is going to go a long way toward avoiding the sort of pitfalls that I think we've already started to see happen out in the wild.
Well, maybe to kind of maybe to leave our listeners with something, a takeaway on that aspect of testing, because that's exactly what you were doing, and you've got the first place to show off for it. If you were to start a list, some suggestions about how someone else could replicate that work, the idea of that work, what would be one or two things that you'd suggest of how they think about doing that type of testing?
So in many ways, the thinking really has to do with sort of societal scale, right? So you have to sort of think of applied context. What is it that this company really would care about from a things going badly perspective? If it's a healthcare company, do they care about having potentially more loss of life because of misdiagnoses, right? And so then if you have that sort of starting point, that creativity maybe is the first step of just thinking about, okay, what does the company care about? How does the company make its money? And then from there, in what context could this system produce responses that are potentially dangerous to, the bottom line, the profits to the company? But then once you've started there, I mean, Microsoft has a lot of stuff, Anthropic, OpenAI, there's a lot of companies out there that are starting to generate a lot of public material for red teaming, but it's not red teaming in the way that we think of it as security professionals. It's red teaming as in more of trust and safety and responsible AI. And definitely going and reviewing those, I think, is a good way to get a sense of like what's possible. And then lastly, I don't know, I think just sort of paying attention to the world around you and maybe, I don't know, expanding your sort of views of the world could be helpful, because it's sort of hard to test for bias if you don't consider something to be biased. And so therefore having an open mind, I think is maybe key to this process in general. Is if you think in a very narrow way, it's going to be hard for you to prove or test for bias, because you're just not going to think of it as being biased. As just, again, humans are biased and we're going to have our own biases. And so having a good sense of your own biases will maybe help you then determine how you could test for things creatively. I don't know. It's very Zen, for lack of a better term.
But it's, to echo back, it shows that it is still early days. It is definitely, as AppSec still after 20 plus, 30 plus years, still remains more art than science. So it's possibly no surprise that the science behind, AI still has some art in terms of its safety and security. But Keith, I love paying attention to you, but I only get to do so for about 30 minutes. But we're definitely going to have to come have you back, because there's a lot more to pay attention about what you've been talking about. But before we do let you go, we've been asking all of our guests to help us build a yearbook of sorts for application security. And we need you to help us fill out this phrase. So complete the phrase of AppSec is most likely to what?
AppSec is most likely to have more buzzwords. Is going to be my phrase. Although if I were more serious, my second one would be AppSec.
That's enough. Trust me.
Boom.
Please, we'll hear the second one, but I love the buzzwords.
AppSec is likely to have more problems, because more code, more software, more problems. That's where I'm going to
more problems and more buzzwords for our vendors to fix them. So yes,
indeed.
Thank you so much, Keith. I appreciate your time.
My pleasure as always. Thank you so much for having me on.
Thanks everyone for joining us. Thank you, John, as well. He did have to duck out, but I promise you, we have not replaced him with an LLM. He will be back in person and in pure humanity on our next show. Thanks everyone for joining us. Remember to subscribe, share us on the socials, check out the show notes, and speaking of machines, check out Turbo Killer by Carpenter Brute. We'll see you next time on Application Security Weekly.